Okay, so now we're going to look at a velocity versus time graph. So the big thing that changed here is the x-axis, or the y-axis. The x-axis stayed exactly the same, still time. But the y-axis is now in meters per second. Okay, so let's read this paragraph up above. In a velocity versus time graph, the slope of the graph represents the acceleration of the object. And that should make a little bit of sense to us because, again, it's going to be rise over run. The rise is the y-axis, which is velocity, which is measured in meters per second. The run is in time, which is measured in seconds. So I'm getting meters per second, or meters per second squared, which we know is a unit for acceleration. Again, the slope can be found by calculating the rise over the run. And if the line is going up, it's a positive slope or acceleration. If the line is going down, it's a negative slope or acceleration. And it asks us to find the acceleration for each section of the graph below. Be sure to give a positive or negative sign. Okay, so pretty similar to what we did before. So here's section A. Pick 2 points along section A. I'm going to pick the first and the last. I've got 0, 0, and then over 4 up 20. Okay, so 20 minus 0 over 4 minus 0, 20 over 4, which is a positive 5. My units, meters per second over seconds, which would be meters per second squared. So I'm accelerating at 5 meters per second squared. Now, I have a positive velocity here at 0, but then it's at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up until I get to 20. So I have a positive velocity and I have a positive acceleration. So since I have a positive velocity and a positive acceleration, I must be speeding up at 5 meters per second squared. I'm going to say speeding up at 5 meters per second squared. Then in the next section, portion B, keep my first point, and now I'm going to be at 7 over 7 up 20. So 20 minus 20 divided by 7 minus 4. 0 over 3, 0 divided by anything is 0 meters per second squared. So if I have an acceleration of 0 meters per second squared, that means I'm not accelerating, or I'm moving at a constant velocity. Okay? So my velocity is not changing, and we can see that. If you look here, the velocity is 20 the entire time. So I did not speed up, I didn't slow down. So I'm moving at a constant speed, okay? And we're not changing direction there either, so here we go. Let's look at C. Okay, so in part C, we start up here with a velocity of 20, and we're going all the way down here. I guess my velocity is maybe around 2. I think it's quite halfway, so I think it's maybe only 2 up. And over 10, up about 2, okay? All right, so now I'm going to find my slope. So 2 minus 20 divided by 10 minus 7. All right, so I get 18, negative 18, whoops, almost forgot that, over a positive 3, which is a negative 6 meters per second squared. Okay, so if I look, my velocity is positive the whole time. I'm going at 20, then like 18, 15, 10, 5. So I'm slowing down, but it's positive the whole time. So I have a positive velocity and a negative acceleration, so it makes sense. Yeah, I'm slowing down. At meters per second squared. So that's my description of motion. All right. Let's look at what's next. I think we're going to look at that in another. Maybe we'll look at what's coming next. Okay, so velocity versus time here. I am going to let you go ahead and look at this, okay, and then I'll get back. Try this on your own.